Okay, so now going on to Module 5, the last module that will be covered in the first exam. Okay, Module 5 is all about correlation, scatter plots, understanding the difference between correlation and causation. Okay, so this first example, we have given the number of calories consumed per day, which is X, and weight, which is Y. You would expect either positive, negative, or no correlation. Okay, so let's think about this. You eat, so let's think about calories, okay, and weight. Now, if you eat more calories, what would you expect your weight to do? Also go up, right? So both the arrows going up at the same time, you would expect a positive correlation. Okay, so basically they are going with each other, right? Up and up at the same time. Now, if the one was going up and the other one was going down, that would be negative correlation. Or if there was really no clear relationship between the two at all, that would be no correlation at all. Okay. So now we have data for gestation periods of in months of randomly selected animals and their corresponding lifespan. So gestational period is like how long, for humans it's 9 months, right? How long you're pregnant. Okay, so first thing, construct a scatter plot for the data. All right, so X, that's gestational, and Y is your lifespan. So make sure we need to go from 0 all the way up to 40. So I'll count by 20s or 10s. Okay, X needs to go from 0 all the way up to, let's see, it looks like 24. So 5, 10, 15, 20, 25. So 5, 10, 15, 20, 25. Okay. So first point is X is 8. So that's here. And Y is 30. That's right here. X is 2.1. So that's here. Y is 12. So that's like somewhere around right there. X is 1.3. So even lower. And then 6. So down here somewhere. X is 1. Y is 3. So even lower. Somewhere around like that. X is 11.5. Somewhere right here. Y is 25. Okay. X is 5.3. Somewhere right here. And Y is 12. So somewhere around right here. 3.8 and 10. And 24.3 and 40. Okay. So that's our scatter plot. What is the most likely Pearson correlation coefficient? Okay. So this is basically the first thing we need to think about. Is this negative or positive correlation? Okay. So yeah, it looks like it's positive, right? As one goes up, so does the other. So as your longer gestational period, the longer your lifespan, right? So this is a positive correlation. One goes up, the other one goes up. Positive slope. That's another way you can think of this, right? So it's not B and it's not E, because those are negative numbers. Now, does it appear to be a strong correlation or a weak correlation? Right? So A is basically like almost no correlation at all. So it doesn't look like that. It does look like there is some sort of correlation. So C and D, difference there is it strong or weak? Well, it does look like it's a strong correlation, right? Because a weak correlation would look something a little more like, so remember, a weak correlation would look a little bit like this, right? And a strong correlation would look a little bit more like this, right? So this one does look to be a little bit more stronger than it looks to be weak. So I would guess that it's the strong correlation there. Okay. Now, I think in the modules we did talk about how to calculate the Pearson correlation coefficient, but in this exam we will not be asking you to actually calculate it, rather just be able to basically interpret that correlation coefficient by doing something along the lines of this example. Okay. The data below represent the number of absences and final grades for 9 randomly selected statistics classes. So what is the direction and the relationship between the number of absences and then the final grade? So this is your final grade, right? 0 absence, very high final grade. 16 absences, very low final grade, right? So as 1 is going up, the final grade is going up. The number of if your final grade is high, the number of absences is low, right? So as 1 is going up, the other one is going down. So that is a negative correlation, right? You can also think of that as being a negative slope. Okay. One more question from Module 5. So now we have a scatter plot for the number of murders and the number of ice cream sold. So as you sell more ice cream, the murder rate seems to increase. Okay, based on the scatter plot, does an increase in ice cream sold cause a higher murder rate? Explain your answer. Okay, so this question is basically asking, do you understand that causation and correlation are not the same thing? So in this case, it's very obvious that ice cream should not lead to more murder, right? As a matter of fact, people get happy when they have ice cream, so you shouldn't be murdering anyone after you've had ice cream, right? So, no, the two variables appear to be correlated, to be positively correlated. However, correlation is not causation, right? So you want to write something along those lines, that ice cream is not causing murders, right? That doesn't make any sense. So the two variables are correlated, but not causally related to each other. All right, so I know I went through a lot of these examples really fast. Always feel welcome to post any questions you have in the discussion board.